Constructing the Built Environment, due 12th of June 2020. This work can be completed by hand or using a computer. Please submit any work you complete, even if you are not sure it's correct. Each slide has an audio option which reads the tasks and gives you helpful hints and tips. Look for the speaker. Task 1. This will take you roughly 20 minutes. Answer the following questions below. They are based on previous works that you have completed at home. So before I read through the questions, this is just a really nice gentle reminder. If there are some work that's been set previously that you haven't finished or you haven't looked at, I really do recommend that you go back and complete that work before you start this lot. I know it means that you're going to be far behind, but I'd rather you be far behind and have a good understanding as to where this is leading to, because this is all one big project. It's all leading you somewhere, and if you skip some work, it might be difficult for you to catch up later on. So I do recommend that you go back, look at that work, complete it, and then complete this later on in the future when you get to it. All right? Okay, so question 1. What is a joist and what does it do? The images below will help you with that, so have a look at them and think to yourself which one of those is a joist and what is it actually doing. Number 2, what material is commonly used to build a joist? Again, images might help you there. Number 3, what is a stud wall? Number 4, what tools can be used to build a stud wall? So again, those images are there to help you, but also a couple lessons back, you actually watched a video that was all about building a stud wall. It lasted about 7 minutes. So think back to that video if you can remember it. If not, you could always do a little bit of YouTubing. Task 2. This will take you roughly 20 minutes. Read through the following slides to help recap the work we have covered previously. So there's about, I think, 4 slides coming up, and it's all work that we've covered in the past, but it was about 3 weeks ago, so I wanted to bring them back to you so you can have a good reflection and just a reminder as to what we actually covered. So, how natural timber is used in construction, and then below we have some images of stud walls, carcassing, and joists in different settings, ceiling and in floor. Construction materials. Technical terms. Joist. Timber that is placed parallel to itself to create large structures that can help hold to support weight for floors and ceilings. Stud wall. Timber used to create a frame which can then be filled with insulation and soundproofing to create a wall. Stud. The timber beams used to create a stud wall. And there's also a YouTube video there which explains all about stud walls and how you can create them. Very, very informative. Highly recommend you watch it. Load-bearing wall. Gives the building structural integrity. So that means it will stand strong and it won't collapse. Load-bearing walls hold and distributes weight from the roof and top floors down to the foundation. So this means that each floor of a building is held up because of these walls. Without them, they would fall down. And below is a beautiful diagram that shows you what load-bearing walls and non-bearing walls look like. Non-load-bearing wall. A wall that can only support its own weight. So it cannot withstand a lot of force. If you were to really bang into it, it would probably fall over. It helps to support the ceiling, but without it, the ceiling would be supported and it would not collapse. So non-load-bearing walls, they're commonly built as a partition, so to help split up a large spaced room. But as it says above, it can't withstand a lot of force. So you could definitely put a few nails in it and hang up a couple pictures, but if you were to run at it full pelt, you would probably put a really big dent into it. Okay, so this is where we're talking about design briefs again. So this is what we talked about last week in the last task. So I'm not going to go over it all over again, but I just wanted to show you where this project is leading us. So we discussed spatial requirements last week, and we're going to continue that, but this time we're going to continue that by actually completing a practical project for you. So again, this is just a little reminder as to what the spatial requirements of a design brief are, and I'm just going to read through them for you. If you missed them last lesson or for the last task, then great, it's here for you again. So I'm going to read it through and then I'm going to explain what these things actually mean. So 3. Spatial requirements. Including dimension plans and elevations, including any special circulation or access requirements that could be compromised by other design features or when the building is furnished or fitted out. Key aspects such as temperature zoning and phasing considerations are also considered here. So let's start from the top and work our way down. So we're going to look at dimension plans and elevations. This is something we've covered before, and this just means that the conventions that are used to clearly show the size of the project in the home and what it would look like before and after the work is completed, so the client can give the go-ahead before work is actually started. Next, we're going to move on to the yellow highlight, which is special circulation or access requirements. So this means how workers can access the site and where materials can be stored safely. So they might have some decorative features in the garden, such as like a water fountain or even an upground pond that would need to be moved in order for workers to come in and out holding large sheets of materials and heavy tools. Okay, so we're going to look now at the green highlight, which is temperature and zoning. So 2 different things there. So temperature is a huge part of construction, as temperature can actually affect the materials in different ways. It's also important that the workers are comfortable in the working conditions. And then zoning, so that means it's the separation of land, so it helps to keep the work organised and keeps clear boundaries as to where workers are actually working and where they can actually go. And then phasing considerations. So a project doesn't actually have to be completed in just one go. It can be broken down into different stages, and these stages should be in a sensible order. That means that pace and progress are constant, so that it's actually finished on time. Task 3. This will take you roughly 1 hour. The next slide shows a plan for our partition stud wall. Complete the following tasks below based on that plan. So, task 1, the plan has been drawn in a scale 1 to 3 in millimeters. Now, if you read that and already are thinking, I don't know what that means, this was the work that was part of last week's tasks, okay, so last week's work. So if you're reading this and you don't know, you can either use the internet to find relevant resources to help you, or YouTube. YouTube's great for this kind of stuff, or look back at the work that was set last week. Okay, continuing with reading the task. Draw out a rough plan. Does not need to be accurate in size, as it will be bigger than an A4 page. And on that plan, label it with 1 to 6 dimensions in millimeters. Some numbers will need to be rounded up to the nearest whole number. So what this is asking you to do, copy out that plan on A4. Doesn't have to be accurate because it won't fit on a piece of A4 paper. And you're going to change the measurements. So instead of it being a scale to 1 to 3, you're going to make it 1 to 6. Okay, so instead of it being 1 to 3, you're going to change it to 1 to 6. So what will you have to do to those numbers to make them twice as big? Okay, moving on to task 2. Use available modelling materials such as paper and cardboard. Build a model of the partition wall at a scale of 1 to 6. The thickness of the model should be 20 millimeters. Now on the next slide, I do have an image that explains to you what the thickness what it actually means. But basically, when you're cutting out all your modelling materials, so your paper and your cardboards, etc., make sure that they're 20 millimeters thick. All right, that way it will actually stand up and you'll be able to glue it or sellotape it quite easily to one another. And then the final task, task 3, label your model to show which are the load-bearing and non-load-bearing studs. All right, so if you're not too sure what that means, just go back a couple slides and the diagrams there will help you. Okay, so this is the plan for the partition wall. All the dimensions here are in millimeters, and this is currently at a scale of 1 to 3. Okay, 1 to 3. And for task 1, the first thing you need to do is draw out this exact same plan. You can include the little arrows as well to help you. And you're going to change those measurements. So instead of them being 1 to 3, they're going to be 1 to 6. And some of them, you'll notice when you do make them 1 to 6, some of them will end in 0.99 or 0.33 or 0.66. you just round it up to the nearest whole number, okay, just to make life a little bit easier for yourself. So this is a slide that helps you understand what I mean by the thickness of the material. So if we look at the plan, it shows you what the width and what the length actually is. So the thickness of the material, in the bottom right hand corner, you could just see that image there. What I would recommend you do is I recommend you just cut a load of 20mm strips. Okay, so just cut a load of them out of paper or cardboard, whatever you're working with. Cut them first, and then you can start measuring them out and actually cutting them to size so that they are the correct length and the correct width to actually make this model. So I'd start that first. Cut a load of 20mm strips, and then you can cut them down to the correct size that you actually need to make your model.